Hi everyone, my name is Mo and I'm the co-founder and CEO of Konnect. We're a Welsh-based startup and our mission is to help cities to move more efficiently and more ecologically. We do this by providing rich insights about how a city's transport and its passengers are flowing, allowing for improvements to be developed, executed and evaluated. So far, with the support of the Welsh Government and the Department for Transport, we've worked mainly within the road sector, producing solutions that detect and classify vehicles, produce turning counts at junctions, and help to monitor and improve the ability for drivers to get from A to B. The lab was an opportunity for us to bring our technology to the rail sector. We started by looking at some of the challenges Transport for Wales faces by the numbers. In 2019 to 2020, 15% of TfW TOC self-delays were caused by station delays. And during this year, where we have seen reduced passenger numbers, the station delay minutes increased by 18% to 61,200. These delay minutes are causing customer frustration and financial impact in the form of compensation payouts. One of the fantastic things about the lab was having the opportunity to speak to many departments and stakeholders within TfW and Keolis Amy. This allowed us to not just use the numbers, but dive into anecdotes of pain points for customers. One example was a discussion around Shrewsbury railway station. Here, passengers changing to or from platform 3 have to leave the station and then re-enter. The time to do this is currently estimated, but it's believed that this estimate may be low. Without data to confirm the actual time taken by passengers to make this change, it's difficult to justify any modification. If the estimate is indeed low and customers are commonly rushing to make their connection, this could be the cause of delays, customer safety issues, and general customer dissatisfaction. We recognize that this and many other use cases could be supported by our product, and to do so, we needed to focus on 5 core capabilities. Firstly, we offer accurate and anonymous passenger detection and counting from existing CCTV infrastructure or our own camera solution where needed. We can then map those detections to station locations to be viewed on station maps or aggregated as heat maps. For trains, we also offer seat occupancy data and statistics around how long passengers take to find a seat and which seats are seeing the most use. In the shorter term, COVID is a key concern affecting passengers' confidence to use rail transport. To tackle this, our passenger detections are enriched with whether a passenger is wearing a mask and how often passengers move within 2 meters of each other. Finally, we can help identify locations where passengers have needed additional assistance, be that wheelchair users, those with heavy luggage, or those with bikes. With this, we can help TfW provide the same great service for all its passengers. So let's take a look at how this works. We take camera footage and using AI detect passengers within the frame. These detections are turned into anonymous locations that can be collected and used for analysis. The original image data is never stored by our system. From our analysis, we observed 82% mask compliance in this footage. We can also do this for trains, as seen here. So what does this look like for those using the data? Well, we offer the data through a number of methods, but for TfW, heavy users of Microsoft's Power BI, we've built custom visuals and tools that help pair our insights with their existing data, giving them the versatility to answer a broad range of questions. We also offer our data through an API, allowing it to be integrated with other software and solutions. And as it happens, we've had promising conversations with fellow lab Cohort 2 member Emu Analytics about pairing our data with their existing geospatial data and technology to help tackle some of the challenges they've been approaching with TfW. As we moved through the accelerator, we produced a number of example Power BI dashboards. Previously, we saw one for stations, and here we have one for trains, showcasing the ability to see the state of a train's carriages before and after a particular stop, as well as seeing which doors were used during that stop. Of course, these capabilities are also possible for buses, coaches, and trams. After showcasing our dashboard to a number of departments within TfW, we conducted a survey. 67% of those that needed accurate passenger counting data didn't have access to it. And 75% of those who said they needed passenger behavior data didn't have access to it. All of those that responded said their tasks would be made easier with access to our data. When asked about the implications of not having access to our data, a pattern emerged. When planning improvements, not enough information is available to make fully informed decisions. This leads to risks that can cause customer dissatisfaction and financial inefficiency. And finally, once the improvements are actioned, there isn't enough data to fully evaluate the impacts of the change and measure its success. Our solution assists all the way through this chain. So in closing, we've had a great time collaborating with TfW, and we thank everyone who's helped us for the support and the advice through the programme. For this last slide, we don't expect you to read it all at once, but here's a list of the capabilities that we can offer currently and some that we are developing in response to requests from stakeholders. Feel free to take a screenshot or pause the video. We look forward to discussing our solution with you in the chat and as well as in the breakout session shortly. Thank you very much.